I want to find dy for y equals 3 cosecant 1 minus 2 square root of x. So I'm going to rewrite this as 3 cosecant 1 minus 2 times x to the 1/2 power. So I'm going to be taking the derivative of both sides. So the derivative of y is dy over dx. Now, for the right, we need to use the chain rule. So we'll be taking the derivative of the outside function, which is cosecant. So the derivative of cosecant is negative cosecant cotangent. So we'll be leaving the inside the same. And then finally, we'll be taking the derivative of the inside, which the derivative of 1 is 0. Bring down the power 1/2 will be negative 1x, and then to the negative 1/2 power. We have the two negatives, so we'll make it positive. So here we can rewrite this. Oh, and also cosecant is 1 over sine. Cotangent is cosine over sine. So we can have 3, and then cosecant will be 1 over sine. So we can have it 1 minus 2 square root of x. And then cotangent is cosine over sine. And then we'll leave the 1 minus 2 square root of x inside. And then we have x to the negative 1/2 power, and that will just be 1 over square root of x. So the last thing we could do, so actually a couple of things. One, we have sine times sine will give us sine squared. So I'll put the square root of x in front. You have sine squared 1 minus 2 square root of x. And the top we have 3 cosine 1 minus 2 square root of x. On the left here I have dy over dx. So I'm going to multiply both sides by dx. So those are going to cancel. And so dy is equal to this whole thing. Okay, next I have y equals 2 cotangent 1 over root x. So this one I'm going to rewrite it as x to the negative 1/2 power. And I'm going to be taking the derivative of both sides. So it's dy over dx. So this one is, again, a chain rule type problem. So we'll be taking the derivative of the outside function. So the derivative of cotangent is negative cosecant squared. Leave the inside the same. And then take the derivative of the inside. So I have a negative 2 and a negative 1/2. So those are going to cancel each other. So I would have x to the negative 3/2 times cosecant squared x to the negative 1/2. And if I want, I can rewrite this as, let's see. We can get rid of all the negatives. So one way to do this is put the x to 3/2 on the bottom. And we have cosecant squared of 1 over square root of x. Okay. And then finally we can multiply the dx's over. So we get dy is equal to that dx. Now let's go look at some product rule. Okay, so what happens when you have a product rule type problem? Solve for dy. So in this case, you can treat it as a differential and just solve for dy. Or another way to do this is whenever you take a derivative of y, you would leave a dy. Whenever you take a derivative of x, leave a dx. So think of this more like a shortcut. And let me show you what I mean by that. Let's look at the first one. 2y to the 3/2. We're taking the derivative of this. So I'm going to bring down the exponent and then subtract 1. And because I'm taking the derivative of y, it's really, dy over dx, but here I'm going to leave it as dy. So I'm going to do this problem a little differently. And I think it's a little quicker. Okay, and then we're taking the derivative of x times y. This is where I have to use a product rule. So the derivative of x with respect to x is 1. But because I'm doing this new way, I'm going to leave dx. And then I'm just going to leave y plus the derivative of y times x. And the derivative of x is 1, so I'm going to leave it as dx, and that's going to equal 0. So again, I have to stress that this is a nice different way of doing it, kind of like a shortcut. So I have two dy's here. My goal is to solve for dy. So I'm going to end up factoring the dy out. And here, these twos are going to cancel. Let's throw the dx's over to the right. So we have 3 times square root of y. I'm going to factor out the dy first. And then it's 3 times square root of y plus x equals dx minus y times dx. I'm just going to change the order there. Okay, so dy is 3 square root y, or dy times 3 square root y plus x. Factor out a dx, we get 1 minus y. I want to solve for dy, so that's going to be 1 minus y over 3 square root y plus x times dx. Okay, so that's my derivative. That's my dy. Okay. We have another problem, so we have xy squared minus 4x 3 to the half power minus y is 0. This one I'm going to still use the dx and dy trick, and maybe afterwards I can show you how to do it the other way. So I'm going to use the product rule here. So the derivative of x, we'll leave it as dx, and then times y squared, plus the derivative of y squared is 2y dy times x, minus 4 times 3 halves times x to the 1/2 power dx minus dy is 0. Okay. So I have, let's see, 4 times 3 halves, that's going to be 6. I have 2 dy's here, and I have how many dx? 2 dx's. So let's just factor out the dy's and dx's. So dy, I have 2xy minus 1. For dx, I have y squared minus 6 square root x. I want to solve for dy, so I'm going to move this whole thing over and then divide it by 2xy minus 1. So this is dy then. So this is my answer. And if you really want, you can distribute out the negative, but it doesn't matter. So that's how to do it using the alternative way. Now I'm going to show you how to use it using implicit differentiation. So I'm going to do this problem on the right, and we're going to compare how much work it took us. So I have x times y squared minus 4x 3 halves minus y is 0. So using implicit differentiation, I'm going to find the derivative of x times y squared. So that's going to be derivative of x times y squared plus the derivative of y squared times x minus the derivative of 4x to the 3/2 power, which is 4 times 3/2 x to the 1/2 power minus dy over dx. I'm going to factor out the dy over dx's and then move everything else to the right. Okay, so that's going to be dy over dx times 2xy minus 1 equals, okay, 4 times 3/2 we said is 6. So that's 6 square root of x minus y squared. I'm going to divide both sides by 2xy minus 1 and multiply both sides by dx. So this is my final answer. And the truth is, this didn't really take us a whole lot of work. And comparing it to the left here, it was actually pretty similar. So either method works.